stone wool insulation a century and a half ago. It was observed that volcanic lava could be whipped into woolly tufts by prevailing winds. Soon, this was being replicated in factories to produce stone wool for insulation. Shaped into bats, stone wool insulation can be tucked snugly between the studs of a framed wall. It acts as both a thermal and acoustic insulator. Here's the soundproofing proof. In this demonstration, an activated alarm goes into a box lined with stone wool. When the lid is closed, the sound is contained. When it's lifted again, the annoying sound is back. They make stone wool from basalt rock and slag recycled from the steel industry. The process is fueled by coke, which is a form of coal. Basalt rock is solidified lava formed when rock melts underground and then quickly cools. After the rock has been partially crushed at the quarry, a loader scoops it onto a screen to separate the bigger pieces from the fine particles. The particles will be processed into briquettes, which can be used in the production of stone wool, along with the bigger pieces of rock. The rock and briquettes, along with the steel slag, melt into lava in a furnace. Temperatures reach 1500 degrees Celsius, as hot as a volcano. A spinning machine whips the lava into thin strands of stone wool in a process that's like making cotton candy. The strands form tufts, and a little binding solution holds them together. A spray of oil adds water repellents. Now a fleecy web, the stone wool rides a conveyor to the factory's upper level, where it spills into a huge pendulum device. The pendulum swings to and fro to layer the stone wool in a zigzag pattern. The number of layers varies, depending on the kind of insulation being made. The now layered stone wool travels between rollers, which compress it substantially, adding density to the wool. Automated pushers tuck in the pack on each side as the wool enters a long oven. The heat cures the binder applied earlier, allowing the compressed fibers to hold their shape. The now tighter pack exits through a cooling zone and travels under a roller which squeezes it to make the fibers more flexible. Circular blades then slice the moving mass of stone wool lengthwise. A branding tool burns the R value and company name onto the surface of the insulation as it moves forward. Robotic arms swing back and forth to slice the insulation to its final dimensions. Instead of sharp steel blades, these robots use high-pressure water jets to make their cuts. The jets do a precise job without generating dust or waste. And the stone wool doesn't absorb the water from the jets. The sheer density of the wool makes it moisture-resistant, along with the oil added to the fibers during spinning. To demonstrate stone wool's water-repellent qualities, they pour water directly onto the surface. There's no absorption. The water just runs off. In this routine test, a worker torches the wool, and it doesn't catch fire. Stone wool can withstand temperatures of almost 1200 degrees Celsius due to its natural properties. It's even cool to the touch on the other side. Once it's passed several quality control tests, the insulation heads for the packaging line. Grippers pull on a roll of plastic tube packaging, and hot jaws cut and seal one end to form an open bag. Mechanical fingers hold the other end open as machinery slides it over a metal spout. A compressed stack of insulation is pushed into the spout. The spout expands, and the insulation is released into the bag. The spout then retracts, and the process is repeated. Machinery heat seals the open end. From a pile of basalt rock and recycled steel slag to a bag full of insulation, it's been a wild and woolly ride.